was asked to kind of show one of these systems of equations in which we have a quadratic and a linear, and we were supposed to come up with solutions for this system. So if you look at it, probably the best way to start is to solve one of the equations for a variable. And at this point, this guy right here is already solved for x. So we know that x is equal for every part of this system in both equations to y minus 7. So what we're going to do is we're going to take the x out of this equation right here. And instead of the x, all right, I'm going to go ahead and put parentheses where the x was. And in this case, all right, we have that problem right there. I'm going to assume that this is y equals. It was sent to me over email, but I'm going to assume that was y equals right there. And we're going to plug in and hope this works out. All right, so if you see, I've taken the x here and I've replaced it with a set of parentheses. The x here is replaced with a set of parentheses. And for now, we're going to plug in y minus 7 into both of these. So y minus 7. Down here, we'll do the same thing. Y minus 7. We'll do our best to solve this quickly. All right. So in this case, we've got y equals, and if I FOILed this out, it would be y squared minus 14y plus 49. It's always this squared, this sign, and twice this. So 7y twice that is 14y, and this squared 49. If I keep going here, we've got plus 2y minus 14 plus 7. All right. I'm going to continue going. And I've got y equals, let's go ahead on this side and we'll combine like terms here. And we're going to combine like terms here and here. We can see this right here is going to be minus 7. And that's going to be a positive 42 when we end up combining that. So we have our y squared. We've got these guys combined, they're like terms, to minus 12y. And then we've got 49 and negative 7, which makes a positive 42. All right, I'm going to continue going here. Let's hope this works out. I'm going to subtract y from both sides here, minus y. I'm going to set this equal to 0, hopefully factor, but if not, maybe we'll do quadratic formula. We get 0 equals y squared minus 13y plus 42. Easy to factor, I believe, all right, because we got a leading coefficient of 1. And anytime you're factoring with a leading coefficient of 1, you go to what multiplies to 42 and adds up to negative 13. Well, the only thing that's going to multiply to a positive is either two positives or two negatives. And since that's negative, we're looking for two numbers that multiply to 42 and add up to negative 13, which in this case isn't too bad. It's going to be a negative 7 and a negative 6. So we've already got our y solutions here. We're going to set both these equal to 0, 0 product property. We're going to go y minus 7 equals 0 right there, which gives us a y value of 7. And then we're going to say y minus 6 equals 0, which gives us a y value of 6. Now, in both these cases, we only have one solution, right? We just have the y values. So I'm going to go ahead and I'm going to use this equation right here for y equals 7. And I'm going to use that equation right there for y equals 6 as well. We're going to plug it in. So this time we're going to say x equals 7 minus 7, which gives us an x value of 0. And x equals 6 minus 7, which gives you an x value of negative 1 for these ordered pairs. 0, 7, one solution, and negative 1, 6, the other solution. So that should be the answer to this equation. All right. Just real quick, here's probably what's happening. All right. So we've got a parabola, and it's 0, 7. Let's see where that would be. 0, 7 would probably be right about here. Negative 1, 6 would be right about here. So we've got a parabola that is somehow being touched by a line that's going through this. And if I was just to guess at this line, which I will, so what would this be? This would be y equals x plus 7. It's going to be something like this as a line. And well, it's got to go through both those points. And then we've probably got a parabola that comes down like this. It's just a guess, touching twice there and there. And that would be the solution system to this equation. Thanks.